Hello all. Welcome to the lecture on signals and systems. And in 1.3 there is a topic called as even and odd signals. Even and odd signals. And the second topic is linear and non-linear systems. So even and odd signals, linear and non-linear systems. So here you need to understand about both the signals and the systems. That is even and odd signals and linear and non-linear systems. Suppose there is a system. There is a system. So what do you mean by a system? So a system is a device or combination of a device. It can be a single step or multiple steps. Okay, which can operate and produces a corresponding response. That is, for any system, if you give any input, there should be a corresponding output. Okay. So, if an input is given to a system and correspondingly if you are getting an output, that is called as response of a system. Suppose if you are having one input and then you are getting one output, if you are having two inputs and then you are getting two outputs, if you are having multiple inputs and you are getting multiple outputs, that is not a problem. So whenever you have an input, you would be getting an output. There are many examples of systems in electronics and communication engineering what we deal normally. Suppose you take a transistor, you will be giving a signal and a VCC input, that is DC input voltage, where you will be getting an amplified output. Then for an oscillator you will be giving a reference signal and a VCC, you will be getting oscillations. And an amplifier, you would be giving an input signal and VCC, you would be getting an amplified output. A half wave rectifier or a full wave rectifier or a modulator or a demodulator or an antenna, anything can be regarded as a system where you are giving one input and you are getting some output. If you are giving multiple inputs, you may be getting multiple outputs. In some cases, such as MIMO antenna, where you are giving multiple inputs and you are getting multiple outputs. A satellite, where you are giving input and parallelly you would be getting an output. Or you may take, for example, a circulator, 3-port circulator or 4-port circulator or n-port circulator, where you are giving n number of inputs and you would be getting an n-1 number of outputs in case of a circulator. So wherever there is input and wherever there is output, that particular entity is defined as a system. That's why we always define in communication engineering as a communication system. That is, you are giving some input and you are getting some output, which is regarded as a system or definition of a system. The output is also called as the response. And systems are classified as linear and non-linear systems, time variant and time invariant systems, static and dynamic systems, causal or non-causal systems, invertible or non-invertible systems, stable and unstable system. Suppose you take an example of a linear and non-linear systems. So in case of linear system, you would be giving an input and output is correspondingly varying with respect to input. Suppose input you are varying and output it is getting varied, then it is called as a linear system. Input you are varying but output it is not varying, then you will be calling it as a non-linear system. Equations are meant to understand, but the basic fundamental is in a linear system, whenever you vary input, output would be correspondingly varying. In non-linear system, if you vary input, the output would be something else. It would not be in correspondence with the input. So these are the basic definitions of linear and non-linear systems. A system is said to be linear when it satisfies superposition. So what is meant by superposition? So here you need to go with the definition of superposition, where The superposition definition itself states that the output is sum of individual inputs, or output is taken accordingly with respect to all the inputs. So a system is said to be always linear when it satisfies one is superposition principle and homogeneous with inputs. That is x1 of t and x2 of t. Suppose they are inputs, you should be getting y1 of t and y2 of t as the outputs, which is called as a linear system. Next, time variant and time invariant systems. What do you mean by time variant and time invariant systems? That is, output is varying with respect to time. It is called as time variant system. Output is not varying with respect to time. It is called as time invariant system. Suppose y of n comma t, where n is number of samples per second and t is the time, y of n minus t. Next, it is a time invariant and time variant systems, y of n comma t, where n is the number of samples and t is the time period, which is not equal to y of n minus t. Now, y of n comma t, where t of x of n minus t is the input change and y of n minus t is output change. Suppose simple parameters if you define, if the output is varying with respect to time, it is called as a time variant system, and output is not varying with respect to time, it is called as a time invariant system. Now next, linear time invariant and linear time variant and linear time invariant systems. A system is both linear time variant and linear time invariant. Okay, a system is both linear and time variant, then it is called as a linear time variant system. And if a system is both linear and time invariant, it is called as a linear time invariant system. That is, see here you need to remember only one point, whether the output is varying with respect to time or output is not varying with respect to time. That is the matter of concern. Now, static and dynamic systems. You may be dealing with many kind of memory systems. A static system is memoryless, whereas a dynamic system, it consists of some memory system. It is called as static and dynamic system. Now, suppose let us see. Y of t is 2 into x of t. For present value t is equal to 0. So y of 0 is equal to 2 into x of 0. So output is only dependent upon present input. Output is dependent upon present input. Here the memory is less or it is static. Suppose example number 2, y of t is equal to 2 into x of t. Okay, plus 3 into x of t minus 3. The present value of t is equal to 0, suppose you take. Y of 0 is equal to 2 into x of 0 plus 3 into x of, if you substitute the value of t as 0, it would be minus 3. Then you would be getting x of minus 3 is the past value. So if it is past value for the present input for which the system requires memory to get this output, hence this system is called as a dynamic system. So this present inputs and past inputs you would be seeing whenever you are dealing with this particular concept called as a feedback. A feedback, it is such a beautiful concept that the present output is being fed to input, where the next output would be based on this present output. So in this way you would be dealing with static and dynamic systems. Next, causal and non-causal systems. Now, a system is said to be causal if its output depends upon present and past inputs, does not depend upon future inputs. Now, you go carefully with this definition. A system is said to be causal if its output depends upon present and past inputs and does not depend upon future input. You can take, for example, feedback amplifier or operational amplifier. If you take it, it is defined as a causal system. Now, for non-causal system, the output depends upon future inputs also. So for this, you need to do small numericals where you have to take the value of t as 1, y of n is equal to t is equal to 1 and y of n is equal to 2x of t plus 3x of t minus 3. And when t is equal to 1, suppose if you substitute 2x of 1 is 2x and 3x of t minus 3 is 1 minus 3 would make it minus 2, and 3x of minus 2 would be minus 6x, and 2x of 1 would be 2x, and y of 1 would be, the value of y of 1 would be minus 4x. So here the system output only depends upon present and past inputs. Why? Because we had got it as a minus 4x and the system is causal. And suppose in example 2, y of n is equal to 2 into x of t plus 3 into x of t minus 3 plus 6x into t minus 3. Suppose take the value of t as 1. You take the value of t as 1. So 2x of 1 plus 3x of 1 minus 3 plus 6x of 1 plus 3. So 2x of 1 is 2x and 3x of t minus 3 is 3x into minus 2 minus 6x, and 6x of t plus 3 is 1 plus 3 would be 4, 6x into 4. So the total equation becomes 2x minus 6x plus 24x and minus 6x would become plus 18x plus 2x will become 20x. So here you are getting a positive value, that is 20x. So for a present value of t is equal to 1, the system output is, he had given the equation what I had done. So the system output depends upon future input. So hence the system is a non-causal system. And invertible and non-invertible systems are, a system is said to be invertible if the input of the system appears at the output. So a system is said to be invertible if the input of the system appears at the output, that is y of t is equal to x of t. Okay. So in the next lecture we will be seeing the total product of these things. And stable and unstable systems means a system is said to be stable only when the output is bounded for a bounded input. So for a bounded input, the output is unbounded. Then suppose you are giving a limited input and you are getting an unlimited output, that is called as unbounded system. So for a bounded signal, the amplitude is final. For an unbounded signal, the amplitude is infinite. Okay. Suppose you may take an example of a ramp signal where the amplitude would be almost infinite. You may get any value of the amplitude in ramp signal. Okay. So these are the different types of classifications of systems. Right.